So the period of the function with this rule here is 3 cos 2 pi t. What is the period? So the formula for period is when you have y equals to a, like sine or cos, and then n bracket like x minus b plus c. So a is the amplitude, b is the horizontal shift, c is vertical shift, and n gives you the period, right?
Okay, yeah.
N is not the period, but n gives you the period.
Oh, okay.
So the period is given by 2 pi over n. So that's 2 pi over, in this case, is 2 pi. So our function is y equals to 3 cos, and then we have 2 pi at the front, and then we have t minus nothing. That's why it's just 2 pi t, and t is functioning as if it's x, and plus nothing, all right?
Okay.
So our n is 2 pi. Therefore, the period is 2 pi over 2 pi, which is 1. So you get this one here. Does everything make sense to you?
Yeah, yeah.
Okay. So this will be recorded, so you can, of course, go back to this recording. All right.
Okay.
So today's lesson is going to include lots and lots of concepts. But obviously, it's going to be helpful when you go back, if you go back to this recording and use the recording while you do other questions. All right. Yeah. So if you actually graph this one, it'll look like this. Because it is a cosine function, it starts from over here, and because amplitude is 3, it starts from 3, and it's minus 3. It starts from there, goes 1 oscillation, then this will be 1 second there. That's time, t, okay?
Oh, is it 1 because that's
because the period is 1.
Yeah.
Yeah, let's go through this one here. So this one is y equals to 2 cos x plus 3. So this is actually a little bit different. It's a plus 3 on the outside, right?
Yeah.
So if you actually draw that, it has been elevated by 1, 2, 3. So that's the middle line. And it also, because amplitude is 2, it oscillates between 5 and 1, okay? So this is 3, 5, 1. So amplitude is 2. See that? So it oscillates from there, up, down, and then up. So that's for one cycle. Then that's, in this case, the period is 2 pi over. You see how there's a 1 in front of it, right? This is 1x. So that's just divide by 1, then you get 2 pi.
Okay.
So the period for that is 2 pi. In this case, the x-axis is just x, y-axis is y. So that's what it looks like. So the question is, what is the minimum value? Of course, you don't actually have to draw this one. The value there is 3, so that's the middle line, and then this is going down by 2 and up by 2. So of course, the minimum value is 1, right? So the answer is C. Do you understand everything there?
Yeah, I get that.
Okay, now number 3, an angle of this much radian expressed in degree. This is pretty simple.
You just substitute 180 into it?
That's right, 180 into pi, right?
Yeah.
Then you get 360 divided by 7, right? Which is 360 divided by 7. That gives you 51.43, this one here.
Yeah.
Alternative way is 2 pi over 7. You need to times it by 180 over pi.
Okay.
But that's the same thing, you know? We get 360 on 7. Next question is, what is the value of x in the diagram here? So this is simple trigonometry here. Well, this one is 3. What's that? Is that this side is 3? No. What are they talking about? Oh, maybe this side is 3. No. This side is 6. this angle is 3, is it?
Yeah, it must be. They wouldn't have given us all three
Otherwise,
sides.
this is not 3, right? So
Yeah.
you're looking for the side, right?
Yeah.
I think it's a little bit messed up. Hold on. Yeah, let me just pause the video. Yeah, we're going to assume that this is 30 degree.
Yeah.
So you have this triangle. This is 30 here, and this is 6 here. And you have to figure out this x here, okay?
Yeah. So you go opposite and
Yeah.
adjacent.
Opposite over adjacent equals to tan 30, right?
Yeah.
So there's no need for, if you ever get a right angle triangle, you don't need to do any sine rule or cosine rule, just have to use simple trig.
Yeah.
Sine cos tan, so 6 over tan 30 is x, but tan 30 is 1 over root 3. So this is the same as, do you know how much?
Same as, no, I don't know yet.
Okay, so what's the 6 divided by 1 on root 3? That's 6 times by root 3, isn't it?
Yeah.
Yes. So you need to swap these two and turn it into times. Then you get 6 root 3, which is this one here.
Okay, yeah.
Okay, now moving on to the next question. So yep, number 5 to number 10. We're going to do that now. Number 5 to number 10. All right, we're going to cut this one, put it down a little. Yep, the smallest value of x for which this graph touches the x-axis is. So this one is solving trig equation. So that means, so you got this curve where this is cosine graph, and this one is elevated by 2. So it looks like this, and amplitude is 2, so it's 4 and 0. See? And it's cosine graph, so it starts from the top. By the way, there are 4 things you need to know. So if it's a cosine graph, it starts from the top and oscillate like this.
Okay.
If it's negative cos, it'll start from the bottom and oscillate like that.
Yeah.
This is for cos, this is for negative cos. Or sine starts from 0 and oscillate like this.
Yeah.
Or negative sine, the function is going to oscillate like this. That's how it starts. Now I can see that this is cosine function elevated by 2. Amplitude is 2, so that's 2 here, that's 2 here. So start from there, oscillate, touches the x-axis there, come over here, and this value is the period. Period is 2 pi over 2, this 2 here, right?
Yeah.
That guy. That 2. So this is equal to pi. So this value is pi. When does it touch the x-axis?
At half pi.
Pi on 2, that's right. So you can solve it like that.
Yeah.
This is a geometrical approach. Another way is you can solve this trig equation by plugging y equals 0, because when it touches the x-axis, that's where y equals to 0, isn't it?
Yeah.
Yeah, so 0 equals to 2 cos 2x plus 2. And then you move that one over there, 2. And then you divide by 2, then you get negative 1 equals to cos 2x. And then you know that for cosine, when does cosine equal to negative 1? So you get 1, negative 1, 0, 0. Remember this stuff?
Oh, yeah.
And for sine, you have sine 1, negative 1, 1, 0, 0. So we know that for 180, you know, so this, whatever this angle is, so 2x must be 180, which is pi. See? And then, of course, that's pi, or we get more answers by doing that's equal to how much? That's 2 pi, 3 pi.
Oh, yeah.
3 pi is, like, you go 1 cycle, that's 2 pi, and then 1 more pi. That's 3 pi, right?
Yeah.
And then 5 pi, 7 pi, all of that, you know? So you can get, divide that by 2, then you get pi on 2.
Yeah.
And then 3 pi on 2. 5 pi on 2, 7 pi on 2. So you know what is these values are? You get this answer here, pi on 2.
Yeah.
Another answer is, you go over here, that value there is 3 pi on 2. So that's half pi, 1 pi, 1.5 pi. This is 2 pi, right? And then you come over here, that's 5 pi on 2, etc., etc. So that's the answer.
Yeah.
Okay. Number 6, sine of x is -1. The value of x is, well, that's pretty simple. Well, you just have to look at this formula here, this diagram. Sine of x is equal to sine of some angle is -1. That's what it's saying, right?
Yeah.
So the answer is 270,
Oh, yeah.
or -90 degree. Or in terms of pi, this is a 3 pi on 2. This is a negative pi on 2, right?
Yeah.
You can generate more answers by going, however many cycles you want. Anyway, so this is only from 0 to 2 pi. That means only within here, okay?
Mm-hmm.
So obviously that's 270, which is 3 pi on 2. This is 3 pi. There's a bit of an error there. What they meant there is 3 pi on 2. So that's the answer.
Yeah.
Okay, so equation of that, where b is a positive real number, has one solution in an interval. The value of b is. Okay, now number 7 is a little bit tricky.
Mm-hmm.
Now, when it says one solution, it's likely to be 1 or -1, because whenever you have sine of something equals to, like, for example, 0.5, that's positive. Sine is positive here and here, right?
Yeah.
So you get two answers. 1, 2. If sine equals to 0, sine of some angle is 0, then you get two answers as well, here and here. This branch and this branch, which is 0 and 180.
Yeah.
When sine is 1, then you only get one answer, this one here, just one branch.
Yeah.
Right? Or if it's a -1, then you get another answer, which is this one. So it's likely to be this and this, okay? So this one is a little bit tricky. It says 2 sine of x plus 1 equals to b. And this has one answer. There's only one answer for x. That means you have 2 sine of x equals to b minus 1. Sine of x is b minus 1 on 2. This has got to be either +1 or -1, right?
Yeah.
So, but it says that b is a positive real number. It's a positive number. If it's a positive number,
It has to be 1.
it has to be, that's right, if b equals to 3, then this will be 1, right?
Yeah.
So let's just solve.
How does b equal to 3?
Yeah, b has to equal to 3 so that this equals to 1.
Oh, right. So,
So
so that whole thing equals to 1. Yeah.
So if this is equal to 1, then you get, if you solve this, you get b equals to 3. If b minus 1 on 2 equals to -1, then you get b equals to -1, which is not allowed. This is allowed.
Yeah. Okay. Yeah.
So
Would you try all? Will it only ever be 0, -1, or 1?
Sorry?
Will it only ever be like 0, -1, or 1 because of the branches?
Yeah, it's the condition is that it only has one solution, right?
Yeah.
The only case where it has only one solution is when is either when it's 1 or -1.
Okay. Yeah.
So if sine equals to 1, then you get one answer here.
You'd get sine
Which
equals
is,
to 1.
yeah, so you get that.
Yeah.
If sine equals to -1, you get one answer, which is just that.
Okay.
So it is a bit complicated question.
Mm-hmm.
Yeah, it's a very tricky one.
Yeah.
But I think you understand
Yeah,
what's
I
going
got
on
that.
here. Yeah, yeah, okay, good.
Yeah, I'll just practice a couple more like that.
Now, we'll try 8 now. So the range and amplitude, respectively, of the function. So here's the function, okay?
Mm-hmm.
So what is the range and the amplitude?
Well, the amplitude's -2.
Okay, so let's draw this. So amplitude is never negative. Amplitude is just 2.
Okay, yeah.
Yeah, so it has been elevated by 2. So that's the middle line. And this is a negative sign. And this is 2 there. So it oscillates between what and what?
It'll oscillate between
So this is 2 here. That's 2.
yeah,
That's 2.
4 and 0.
4 and 0. That's right. Does it? So can you draw this one? Can you then draw this? I'll leave it to you. So you can
Yeah.
use your mouse to draw. Maybe I'll make it look a bit bigger. Yeah, give that a go.
Do we have the key? Is it from the?
Yeah. So the equation was y equals to -2 sine x plus 2. So that was that one there. Okay.
Yeah.
Can you control your mouse?
I don't think. Oh, now I can.
Yep.
So it's
That's excellent. Very good. Let me get the control back.
sorry, that's a really bad line.
No, that's okay. So you've done a fantastic job with just mouse. So that's 1 period, right?
Yeah,
And that value there is
that's 2 pi.
2 pi because the period is given by 2 pi over n equals to 1 in this case.
Yeah.
So that's 2 pi, so that value there is pi, that value there is pi on 2.
Yeah.
And that value there is 3
3
pi on 2. Okay, now, so the question is, what is the range? Range is the allowed x values, right? So this is actually domain is R. Domain is R, so that means this goes on forever like this. Doesn't stop.
That should be infinity to infinity.
So domain is infinity to infinity.
Yeah. But range would be.
This is not range.
Oh.
Yeah, range is, this is not range. This is called codomain, which simply includes the range.
Yeah.
So just by looking at this one, you can never work out the range. You need to actually look at the graph to figure out the range. Okay. So the range is from 0 to 2 or -2 to 2 or 0 to 4 or -2 to 0. Which one is it?
0 to 4.
0 to 4, that's right. So I think this is the answer to this one, right?
Yeah.
Amplitude is? Amplitude
2.
is 2 because it's -2 here, right?
Mm-hmm.
Now number 9, a period of the function, this function here, there's no c there, right? It's just a and b. Anyway, the period of this function is 2 pi over
B?
b, that's right. 2 pi over b, that's right. This one here.
Yeah. Why did I keep writing 2p?
I don't know. Yeah, it's just an error.
Yeah, it's all good.
So when they type, like this is generated by computer typing, so they should write like /pi, then this generates pi, but then maybe they forgot the I bit.
Yeah,
Yeah,
probably.
it's a computer language. Number 10, vertical distance from ground to a point on the wheel as it rotates is given by this. So vertical distance from ground to a point on a wheel as it rotates is given by that. where t is time in minutes. What is the time in seconds for a full rotation of the wheel? Okay, so let's say there's a wheel and you have this point, okay?
Mm-hmm.
And what's going to happen is as this wheel goes this way, this point here
Goes over.
kind of goes through some sinusoidal motion.
Yeah.
So let me show you what that means. Point on wheel in motion. It looks really interesting. So as the wheel goes, it creates it traces this path.
Yeah.
Okay, so we're going to actually have a look at that in motion. In Java simulation. Let's have a look at that. Can you see that?
No, I can't see anything yet.
I mean, does this one show this one here?
It's just a black. Oh, now I can see it.
You can see it?
Yeah. Sorry, it was just a black screen.
Okay. So that point there
Yeah.
traces this sort of a path, doesn't it?
Yeah.
Anyway, but anyway, it creates a function like this, and that function is given by that.
Oh,
So
okay.
this is a function that is describing how this point is moving. Okay?
Yeah, but it's not like sine or cos or anything?
Well, it's actually quite different. This is not like sine curve. This is like bouncing off, right?
Yeah.
Where a sine curve is going down and up and down and up, right? So anyway, so this is vertical distance from the ground or point on a wheel as it rotates given by that. So we're not going to think too much about the physics. We're just going to accept this one as a fact.
Yeah.
T is in minutes. What is the time in seconds of a full rotation of the wheel? So the answer is simply for full rotation, that's just talking about the periods, 2 pi over 8 pi.
Oh, okay. 2 pi over 8 pi. So you just have quarter pi.
So it's a 1 on 4. That's in minutes. The reason is, it says T is in minutes, right?
Yeah. And we have
So
to give it in seconds?
in seconds, that's right. So the answer is 15 seconds.
15. Yeah.
Because 0.25 times by 60 gives you 15 seconds, right?
Yeah.
So that's up to question 10 now. I think the most, yeah.
So I should just try not think about, like, with those questions, the like what it's saying as such with the wheel, but more just look at the numbers.
That's right. So all it was asking was, what is the period? And that's 2 pi over 8 pi.
Yeah.
That's the number in front of the variable t, right?
Mm-hmm.
Now we're going to move on to the next question, 11. Yeah, 11. I'm going to try 11 now. Okay, so one cycle of a graph of a function of this equation has a vertical asymptote of this and this. So this is pi here.
Mm-hmm.
Possible value of a is, all right, now you need to know that tangent graph looks like this. Up, and then there's asymptote.
Yeah.
And then there is like that, and that's basically pi. So we know the period of sine and cos is 2 pi over n, right?
Yeah.
But for tangent, remember, for tangent, it is pi over n.
Okay.
Not 2 pi over n, okay?
Yeah.
So if I draw y equals to tan of x, it'll just look like that, and it'll go like this, and then it'll have another asymptote here, and then arrive back to 0. That's where 2 pi is.
Yeah.
But obviously, for one cycle is simply from there to there, isn't it?
Okay, as opposed to the full line.
Yeah. So instead of going to 2 pi, within 2 pi you have 2 cycles. Another one here and here. See? That's for 2 cycles.
Yeah.
Now, it has, so whatever this function is, this one is taking y equals to tan of ax. So of course a determines the period. Period is 2 pi, pi over
Pi over n.
a. Now
Oh,
asymptote is here. And instead of, this used to be pi on 2, this used to be 3 pi on 2. We've got an asymptote here, which is at pi over 6. And this over here, which is negative pi over 6. So they give you that. Of course, you get another asymptote here, you know?
Yeah.
So usually you get one asymptote here, which is pi on 2, and likewise you have minus pi on 2. So you get the similar thing here as well. So of course the graph is going like this and like that.
Yeah.
Now from this, you need to figure out the period, and then you need to figure out a. So I'm going to give you some time for it.
So I'm finding, oh, so it'd be pi over 6 times 2.
That's right. So the period for this one is going to be over here, right? That's for one cycle. So this one times by 2 is 2 pi over 6, which is a pi over 3.
Yeah.
That's the period. So period is pi over 3.
Yeah.
But the formula for period is pi over n.
Oh, okay. So now I have to go.
So n is 3, isn't it?
Yeah.
So that's why a is 3. So the equation is y equals to tan 3x. So
Yeah.
a equals to 3.
Okay. Yeah, that makes sense.
So because a was 3, the period was pi over 3. And pi over 3, that's why, because the period is pi over 3, you get an asymptote here, pi on 6 and negative pi on 6.
Yeah.
And we were sort of working it backward, okay? Yeah. As homework question, you can maybe try this. It's got period of, it's got an asymptote, another asymptote at 2 pi over 3 and negative 2 pi over 3. Okay?
Yeah.
Then what is the equation? What's the value of a? So you can try that as homework. Okay?
Okay.
The answer is
Would be 4 pi.
3 on 4, I think.
Oh.
Yeah. This should be the answer, I think.
And is that doing the same by going 2 pi over 3 times 2 and then just using the bottom?
So that there and that there, of course, the period is 4 pi over 3, right?
Yeah.
Now, period is pi over n. Well, in this case, n is a, right?
Yeah.
And the period is 4 pi over 3. And this is a pi over a, right? So you need to figure out a. Pi cancels out. And a equals to 3 on 4.
Oh, okay.
So if you just solve that, you get a equals to 3 on 4. Okay?
Yeah.
Yeah. We just have to try many questions today. So we're just going to skip minute details.
Yeah.
Because I think you can go over it again. Now, 12, 13, 14. Okay, so what's the maximum value of that? The answer is 12. Do you know how I can work that out quickly?
Yeah. No.
Okay. So it's pretty simple. The elevation is 2. So the equation for this is y equals to negative tan sine of 3x plus 2. So the graph of this is elevated by 2, and it's going to oscillate between 12 and -8 because the amplitude is 10.
Oh, okay.
You add 10, then you get 12.
Yeah.
And then you subtract 10, you get -8, right? So the maximum value is 12, minimum value is -8.
Yeah,
And
that
because it's
makes
a
sense.
negative sign, it's going to go down, up, and down. So that's the line of equilibrium. Maximum value is 12.
Yeah, got that.
And because for one cycle, that value there is 2.3. So that's the period. Okay, sequence of transformation which transform the graph of this to graph of that is, so y equals to tan of x. This turns into y equals to -2 tan of x on 3. Okay. So obviously the first graph is, you get that, asymptote, and then that's equal to pi. And for this one, the period is pi over, you see how that's a 1 over 3?
Yeah.
That's a 1 over 3, so pi over 1 over 3. That's equal to 3 pi. Period is 3 pi. So the graph of this is going to go like this. This is 3 pi. And because it's negative, rather than going up, it goes down. And then there's asymptote.
Yeah.
And like that. And that's 3 pi. So you have an asymptote here at 3 pi on 2. That's the graph of that one there. Okay.
Okay, yeah.
So what's the transformation is it going? So it is going from, so this used to be pi, but this is now 3 pi. So if I draw them on the same scale, this is pi, this is 2 pi, this is 3 pi. So whatever this graph is, it is going to be somewhere like this. That's 3 pi, and this bit here is now this bit, or sorry, it's going to be now this bit, and then this bit here has now been flipped to become that. So it's a lot bigger graph, okay, stretched horizontally. So this is dilation of factor of 1 on 3. It's not going to be dilation of 1 on half or 2, so cancel that out. It's going to be dilation of either factor of 3 or 1 on 3 on the x-axis, followed by dilation of factor of 1/2 in the y-axis, and then reflection around the x-axis. So I'll tell you what all this means, okay? So the negative sign there means reflection around the x-axis. And this 2 here, that's amplitude, right? Amplitude is always something that works on the y-axis. So this is dilation on the x-axis, y-axis, sorry.
Yeah.
And always the period is dilation around the x-axis.
Yeah.
So there is definitely, so the answer is between A or B, or A or D. I want you to make a choice.
I think D.
D?
Yeah.
Yeah, so it is dilation of 3. Because if it's 1 on 3, then it's 3. If it is 2, then it's 2. It's not 1 on half, okay? 1 on 2. So for dilation around the y-axis, you take this value as it is. Of dilation on the x-axis, you just have to flip this one. And that'll be the dilation. And then there is reflection around the x-axis because of the negative sign here, right?
Yeah.
Yeah, so the answer is D. That's very good. We're going to try another one. Try another one. We just did 13. We're going to try 14 here. Okay, so sequence of transformation which transform the graph of that to this. So I need to know that this equation here is better written as -3 cos 2x plus 3. You need to know how to plot this one. So -3, so it's gone up by 3.
Yep.
And amplitude is 3, so 0 and 6, okay?
Yeah.
I want you to plot this one. So that's 2 there. So I'll give the control over to you.
Mm-hmm. So it would be -3 is the amplitude. And
3 is the amplitude.
oh, it's negative.
We always take the positive value of the amplitude. Yeah, we always take positive value.
Oh wait.
Take your time.
Is that right? Actually, that doesn't look right.
So it is cosine graph, but it's negative cosine, isn't it?
So it's the other direction.
Yeah, the other direction. So let's cancel that. You can try again.
So it's from down here.
Mm-hmm. Let's make it a bit more flat on the bottom there. Well, no, a bit more flat.
Oh.
Like this. I'll do it. Like this. Okay. Sort of like that. No. So it's a bit hard to control with the mouse. Yeah.
Yeah.
But you know what I mean, right?
Yeah, yeah.
Yeah, you can try.
Oh, yeah, I do. Is that what you meant?
Yep. That's very good. All right. So let me get the control back.
Mm-hmm.
So we've done an excellent job there. So I'll draw the original graph. Original graph is, so this value here is, because the period is 2 pi over 2.
Yeah.
This is pi, okay?
Okay.
Now the original graph is cosine of x, right?
Yeah.
And this is 3 here. 1 is just about here and here. And this is 2 pi. So original graph was sort of between this line and this line.
Mm-hmm.
And it was going from there. Cosine was starts from there. Like this.
Yeah.
And like that. So that's the original graph, but then it sort of got compressed and then elevated up, right?
Yeah.
And not only that, it started from there, but it's now starting from there instead of here, right?
Mm-hmm.
So I want you to look at all these choices.
Yep.
And figure out which one's the answer.
Would it be E?
A, okay, let's have a look. So dilation of factor 3 from the, so if it gets dilated, that means by 3, that means it gets longer.
Oh, so
But
it
it's
has to be
actually
like 1/3.
1/3, that's right. Yeah.
Right, because if it goes over 1, then it's going to stretch.
Hold on. I think they messed up here. It must be dilation of 1/2 or 1/2 or 2. I think because there's a 2 here. See?
Oh, yeah.
Yeah, I think they considered they put a 2 there, but they all have a 1 on 3, 1 on 3, or 3 or 3, right? So I'm gonna assume that this is 2, and 2 there, and 2 there, and 2 there. Okay, so I don't think it's C, D, A. All right, it must be dilation factor of 1/2. Followed by dilation of factor of 1/2. Or they switch these two around. This is a 3 here, 3 here. But that's the amplitude, right?
Yeah.
So I think it's a dilation by factor of 3 or 1 on 3. 1 on 3 means it gets smaller. 3 means it gets larger.
3.
So just 3, right?
Yeah.
So and reflection in the y-axis. Ooh,
So,
it's a bit reflection around the y-axis. Actually, reflection around the x-axis because of the negative in front. And then translation of 3 units. That's right. Translation of 3 units up, isn't it?
yeah.
So I think it's a little bit messed up question. So this must be x here, and then I'm not really sure what the answer is because it's all messed up. But so the answer is this one. Okay.
Yeah.
We're just going to change it to the way we want. So it's going to be 1/2, 3. Around the x-axis, you see how this one gets flipped around the x-axis? So that goes up to over here, and that goes to the bottom here. That's why you get that. And that goes to the bottom here, so that's why you get that here. And then it is moved up by, yeah, that's right, moved up by 3 units in the y direction.
Yeah.
Yeah. Yeah, so we're gonna move on. So this worksheet, there are a lot of errors. Now, we're gonna try 15, 16. I'm not sure how many questions we got. They're short answers as well. So maybe you can try that as homework.
Yeah.
Now, moving on. Let's try this. So 15 first, the graph of the function equation of y equals to cosine x is transformed by a dilation of 3 from the x-axis, and then translation of that in the negative direction of the x-axis, and 1 unit in the positive direction of y-axis. The equation of the image is given by. So you can give it a go. First of all, should we have 3 here or 1 on 3 here?
1 on 3.
That's right. For dilation in the x direction by 3, you need to have 1 on 3. Instead
But
of
if
3.
it was y, it would just be 3.
If it's y, then you just have 3 on the outside, like this.
Yeah.
So this is dilation by 3 in the y direction.
So it would be,
Yeah. So I don't think there is any dilation in the y direction, so cancel that out.
yeah.
I think the answer is either C or E, right? Because it's got 1 on 3, 1 on 3. It's going up by 1. So should that be positive 1 or negative 1? Positive 1. And if it is moving in the negative direction in the for x-axis, then it's actually positive here.
Yeah.
So if in summary, I can write it this way. So if you want to move to, if you want to have x plus a, let's say a is a positive guy, this will move to the left. If x minus a, this will move to the right, okay? And then if you have 1 over a and then x, x minus, let's say 1 over n, let's say like 1 over a times by x something, then it'll stretch by a factor of a. If you've got a x whatever, then this will compress. So this will be like dividing by a. So it's just works the opposite way for x. Now, if you have y equals to some sine function here, or cosine, and then plus a, right? Then that's moving up by a. If we've got some stuff, so y equals to some stuff here. So this is actually sine or cosine of that, sine or cosine of that, and sine or cosine of that, and sine and cosine of that. If you've got y blah plus a, that's moving up by a. Y blah minus a, that's moving down by a. If you've got y and then a and then sine or cosine something, that's what? That's stretching times in by a. And if you've got y equals to 1 over a, and then sine or cos, this is compression.
Oh.
So it's just completely opposite, isn't it? So if it's plus, we're left. If it's plus, then it's up. Negative, then it's to the right. Negative, then it's down. If it's divided by a, then it's stretch. If it's multiplied by a, then it's stretch. If it's multiplied by a, then it's compress. Divided by a, then it's compress. So this is the summary of all the graph transformation for sine cos. Works the same way for tan as well. So the answer is C, of course.
Yep.
And let's try to plot this one without any use of calculator. So this one is cos of 1 on 3, like that. And then you have this one is period is 2 pi over 1 over 3. Do you know how much that is? You need to know how to figure this one out. You know, when you have 2 pi over 3, that's just 2 pi over 3, isn't it? But when you have 2 pi over 1 over 3, this is actually 2 pi times by 3. So this is 2 pi divided by 3. This is 2 pi over 1 over 3. That's 2 pi times by 3, so it's 6 pi. So that's going to be the period. And it is elevated up by 1. Amplitude is 1, so it's going to oscillate between 2 and 0. 2, 1, 0. And without this pi on 2, it would have been cosine starts from here, oscillate down and up and down, and then you get 6 pi there. Okay? So that would have been the graph of cosine 1 on 3 x plus 1, okay? But obviously there is a pi on 2, so this is actually 3 pi. Well, this is 2 pi, 1 pi, that's half pi, so it's only moving slightly. So this whole graph is going to move, it was like that, but then it's going to move to the left or right because of this pi on 2. Is it going to move left or right?
Right.
It's going to move to the left.
Oh, yeah, because it's
Because of this one.
negative.
Positive, that's right. So it's going to move. So I think this is 3 pi, 2 pi, 1 pi, half pi is somewhere around there. It's very, very small, insignificant amount. So that point is going to move to the left like that.
Yeah.
So that's going to be the graph of it, okay? So whenever this horizontal shift is applied, the graph gets a little bit more difficult to plot, okay? Now, I don't think we need to worry about, have you done the R sign method? I'll just go through it anyway. So you got the, you know what sine of A plus B is, right? So that's a sine of A, cos of B, plus cos of A, sine of B, true? So we want to write this one in this form. So what that means is we've got, so this needs to be sine, cos, sine in order to, hold on, sine of x. So I'm going to write this one as sine of x minus cos of x. And you can see this is a bit complicated. So this is the same thing as this one, right? This is the same thing as this one. Now what we do is, this is 1 here. This is 1 here. So just draw a triangle with, so I need this to be cos. So I'm going to write it as 1 here. And I need that to be sine. So that it's sine, cos, sine. Sine, cos, sine is going to be sine A plus B. So I'm going to put that over here. And this is root 2. And this one is 45 degrees, which is pi on 4. Now what happens is, this 1 over root 2 is equal to cosine of pi on 4. And that the other 1 over root 2 is sine over pi on 4, like that. So therefore, this 1 is equal to root 2 cosine pi on 4. This one here is root 2 sine pi on 4. So I can rewrite this one as sine of x, and then root 2 cosine pi on 4, cosine pi on 4 with root 2 at the front, minus cosine x times by this one. So root 2 comes out to the front, and sine pi on 4. And what happens is, this is root 2 sine of x cosine of pi on 4 minus cosine of x. I'm going to do some abbreviation, and sine of pi on 4, which becomes root 2. And then this is sine x cos, is exactly in this form, but with a negative sign. So this becomes a sine of x minus pi on 4, which is actually none of those, but it is the same thing as, let me have a look at this. So it's, we know that negative pi on 4 is the same as 7 pi on 4, right? Because it's negative pi on 4 is the same as positive 7 pi on 4, so the answer is D. Anyway, so this is a very difficult one, this one, okay?
Yeah.
That was the last question from this worksheet on the free response question.
Uh-huh.
Yep, that was the last question. And you can try question 1 through to question A here. It's only a 2-page long. You can try that and let me know, okay? Maybe
Yeah,
try that now, and then get back to me.
Okay, sounds good.
Yeah, we'll call it a day here. See you next time.
Cool. Thank you. Bye.
I'll send you the recording as well.
Awesome. Thanks.